If you've read the book Gulliver's Travels by Jonathan Swift, you'll remember that Gulliver said he visited a land of giants. He said they were 12 times taller than he was, and therefore 12 times as strong. Let's see if we can find out if Gulliver was telling the truth. The science of physics and measurement can give us the answer. First, let's look at a boy. Suppose he's 5 feet tall and weighs 100 pounds. Now, if he were 10 feet tall and his proportions remained the same, he'd weigh 800 pounds. Why? Well, this cube will show us why. It's 1 inch long, 1 inch wide, and 1 inch high. To double its height and keep its proportions the same, we must double its length, its width, as well as its height. We've had to use 8 cubes, as you can see. If our original cube weighs 1 ounce, then our big cube must weigh 8 times as much, or 8 ounces. When the dimensions of any object, regardless of its shape, are doubled, it will weigh 8 times as much. So, if the boy were twice as tall and kept his same proportions, he'd be 8 times as heavy. But he wouldn't be 8 times as strong. Why? Well, his body is held up by a set of bones, a skeleton. The strength of a bone or a muscle depends upon the area of its cross-section. A cross-section of a bone is a slice through it. Because a cross-section is an area, it has only length and width. When the small cube doubled in size, 3 dimensions doubled: length, width, and height. But its cross-sectional area, a slice through it, doubled in only 2 dimensions, length and width. Let's see what happens if the size of a large animal increases. If the height of this elephant doubles, and its length and its width also double, its weight, like the boy's, increases in 3 dimensions, or 8 times. But the cross-sectional area of its bones and muscles, its strength, increases in only 2 dimensions, or 4 times. Thus, the weight of a double-sized elephant increases twice as much as its strength. That's why doubling the boy's height and keeping his same proportions makes him 8 times as heavy, but only 4 times as strong. 1/2 as strong proportionately as he was before. What if a mouse were as big as a boy? A large mouse on its hind legs may stand about 6 inches high. If the boy is 5 feet, or 60 inches high, and the mouse is 6 inches high, then the boy is 10 times taller than the mouse. Now, if the mouse were the boy's size, its volume and weight would increase 10 times for the length, 10 times for the width, and 10 times for the height, or 1,000 times. But the cross-sectional area of its bones, and so its strength, would increase only 10 times 10, or 100 times. The bones of the mouse would have to support 10 times more weight than they did originally. Each time our oversized mouse took a step, its bones would snap like toothpicks. As you can see, big mice have a very dim future. Here's another example. This beetle is very strong. It's able to pull a heavy toy wagon. Now, what if the beetle were as big as the boy? How strong would it be? The beetle is 1 inch in length. If it were 5 feet or 60 inches in length, its volume and weight would increase. 60 times for the length, 60 times for the width, 60 times for the height. A total of 60 times 60 times 60, or 216,000 times. But the strength of muscles, like bones, depends upon the area of their cross-section. The beetle's strength would increase 60 times for each of only 2 dimensions, 60 times for the length and 60 times for the width. A total of only 60 times 60, or 3,600 times. So a beetle as large as a boy would not have strength enough to lift a glass of milk. It couldn't even exist. Now, what happens when we decrease size? What if the boy were as small as the beetle? The boy's volume and weight would decrease 60 times for each of 3 dimensions. 60 times 60 times 60, or 216,000 times. But the cross-sectional area of his muscles would decrease 60 times in only 2 dimensions. 60 times 60, or 3,600 times. Since the boy's weight decreased 60 times more than his strength, the boy becomes 60 times stronger in proportion to his size than he is now. If a body is made smaller in all proportions, its strength does not become smaller by the same amount. In fact, the smaller a body becomes, the greater its strength in relation to its weight. If a body is made larger in all proportions, however, the less its relative strength, because the relative weight it must carry is greater. Do you remember our question about Gulliver? He said the giants he visited were 12 times taller and 12 times stronger than he was. Was Gulliver telling the truth?